All right, hi, algebra students. So today is the first day that I am out, obviously. So we're going to try having videos that I record the notes on. You guys are responsible for taking notes on this, so you're going to need to pause and rewind the video as necessary. But do keep in mind while you're taking the notes that this video will be available on Schoology, so you can reference it at a later time. So on Friday, we did an activity that kind of got us ready for slope, y-intercept, and what we call slope-intercept form, named for the fact that this equation includes both the slope and the y-intercept, which hopefully you discovered on Friday. So we start off here with the idea of slope and just kind of some definitions. So slope is a word you're going to hear a lot in algebra and further math classes. First of all, slope describes the steepness of a line, how steep it is. You can also call it rise over run, how fast it rises as the line runs. The more technical term for it and the more technical definition is the idea of change in y over change in x. This piece here says the same thing. This triangle is called a delta, and it means change in. And then finally, we use the letter m to describe slope. Last year, when we did constant of proportionality, which is a version of slope, we used the letter k. This year, we're using m. Next, as we discovered on Friday, we have something called the y-intercept. So intercept is a word that means to cross. So the y-intercept is the starting point. It's where the line crosses the y-axis, and the letter we use for this is B. Do not ask me why, but it's the letter we use. Okay, so some notes. Not that this was the first thing you're writing down, but you definitely want this if you haven't been writing down. Slope-intercept form is another way of saying function form. Notice that we have solved for y, our output, and our input is over here in the problem, x. However, when dealing with slope-intercept form, the y and x are not our main concerns. We are more focused with m, slope, and m is always being multiplied to your x. And we're very interested in b, our y-intercept, which is always being either added or subtracted to your x. Now, in order to graph using slope-intercept form, we follow these steps. The first thing you're going to do is plot your y-intercept, so your b. And the second thing you're going to do is you're going to use your slope to count your rise and run. Now, we've already learned how to calculate slope on a previous day. And we talked about that you should leave your slopes in fraction form so that we know how much to rise and how much to run. After today, you guys are going to be looking at me asking, why did I ever make you graph any other way? So here we have an example. Hopefully you guys have some graph paper nearby so you can do this example in your notes. If not, pause it, go get one, and just sketch a real fast x and y axis. It does not have to be beautiful. So following our steps here in order to graph, what we would normally do is we would make a table, plug in an x, and get our output, our y. But we don't have to do that. The first thing we're going to do is we're going to plot our y-intercept. So I see here that my intercept is -5, because I have to pay attention to that subtraction sign there. So the first thing I do is I come over and I plot a point at -5 on the y-axis, because it's our y-intercept where it crosses the y-axis. The next thing I do is I use slope to count my rise and run. The biggest issue that kids have with slope is they forget that y is on top and x is on the bottom. So we have to make sure that we count up first and then over. That's why we call it rise and then run. So according to my slope, I'm going to count up 1 because it's a positive 1, and to the right 4 because it's a positive 4. So I'm going to count up 1 and then 1, 2, 3, 4. Now, I always want to make sure that I have 3 points before I make a line. And if I look here, I don't have enough space to count up 1 and to the right 4. But using my integer rules, I know that if I make both of these negative, it's still technically a positive number because a negative divided by a negative is a positive. So I could also go down 1, because it's a -1, and back 4 since it's a negative 4, and this will still show up within my line. Now you guys will use a ruler when you do this for me, but I am doing this on my computer, so I don't really have access to a ruler. So we would connect our lines. Because it is a line and not a line segment, we will put arrows on both sides. Okay, here's another example. So again, using my notes here, I first start with the y-intercept, and the y-intercept is what's being added to my x, so this is my y-intercept. So I go up to the 2 on the y-axis, and I plot my starting point. Over here is my slope. And some of you might be wondering, Miss K, it's not a fraction. How do I graph my rise and run? Well, we know that if you take any integer and place it over 1, it becomes a fraction. Now, pay careful attention to the fact that this 3 is negative. That tells me that I count down 3, and my 1 is positive, so I go to the right 1. Okay, so I'm going to go down 3 again because it's a negative 3, and I go to the right 1. Now, all I care about is that my fraction is negative. So it doesn't matter if the numerator is negative or the denominator is negative. So negative 3 over 1 is the same thing as 3 over negative 1. It doesn't matter which number in your fraction is negative. So I could also graph this as a positive rise, up 3, 1, 2, 3, but a negative run and go back 1. And you'll see that I still end up in this line. You can't make both numbers negative. I'll show you why here in a second. If you see that negative sign out front, you can't make both of them negative, because if you do a negative 3 over a negative 1, we know a negative divided by negative is actually a positive. So by making both numbers in your fraction negative, you're actually creating an unequal fraction. So be really careful with that. Okay, another example. Again, I start down here at step 1, and I'm going to plot my y-intercept. So my y-intercept is what is being added to x. So I see it's a 4. So I'm going to go to the y-intercept, plot a 4, and then I need my slope, but there's no number in front of the x. However, being algebra students, we all know that if there's no number, that actually means there's a 1 in front. And because I want a fraction, I'm going to go ahead and put it as 1 over 1. There are no negative numbers here, so it means a positive rise and a positive run. Positive rise and a positive run. Or I could make both numbers negative, because a negative divided by negative is still a positive, and I could go down 1, back 1, and I still end up within my line. You guys are going to know when you make a mistake here pretty quickly if your dots don't come up in a straight line. We are dealing with linear functions, meaning straight line functions. Okay? Now, I would very much like it if you guys would pause this one. Even if you haven't been graphing with me on the previous ones, go ahead and pause, graph this on your own, and then double check to make sure that you have it right. Okay, so hopefully you paused the video, gave this a whirl on your own, used your notes if you didn't remember your steps, because I don't have them down here this time. So first thing I'm going to do is I'm going to graph my y-intercept. So I go up to 1, plot my point, and now I need to graph my slope. Here I see that my rise is negative, so that tells me to go down 1, and my run is positive, so I'm going to go to the right 3. But again, as we talked about before, it doesn't matter which one is negative as long as just one of your numbers is negative. So negative 1/3 is equal to negative 1/3 with the negative in the opposite position. So I could do a positive rise and a negative run and still end up in the same line. So hopefully your graph looked like mine. If you guys are having trouble, I have no idea how well the sub is with math, so you can try her for help, but I think probably your best resource is going to be another student in the class who felt that they grasped this concept. Okay, writing the equation of a line. So to write the equation, you still follow your same steps essentially. So I know my equation is going to be y equals, my slope is going to go here, my x is going to be multiplied toward it, and I'm going to add my y-intercept. So again, we're going to start with our y-intercept. I see it's a 1.